Hello friends, now I am Gopal Agarwal, again student of biotechnology in Mohali, and as a part of Pharma Toppers, I bring to you my second slide for enzymes, that is enzyme part 2, and today we will discuss Michaelis-Menten's equation, right? So before doing Michaelis-Menten equation, let me ask you a very simple question: what is enzyme kinetics, right? So the answer of enzyme kinetics is it is a study of the mechanism of the enzyme catalyst reaction in order to determine the rate of reaction and how it changes in response to the change in the experimental parameters. So it means that enzyme kinetics is a study of mechanism. How does a enzyme catalyzes a reaction, right? Why we are studying this mechanism? In order to determine the rate of reaction. Rate of reaction is what is the change in the substrate concentration, or what is the change in the product formation per unit time, right? What is the change occurring, that is the rate of reaction. How fast the reaction is proceeding, that is the rate of reaction, right? And how it changes in response to the experimental parameters. Experimental parameters means if we increase the temperature, does it affect the rate of reaction? Yes. If it decrease the temperature, does it affect the rate of reaction? Yes. If we lower the pH, does it affect the rate of reaction? Yes. These are the various experimental parameters that are always been studied, right, in response to study the rate of reaction, and this studying of rate of reaction is called as the enzyme kinetics. Enzyme is a word, kinetics is if you merge these both the word, it is just to study the kinetics, how the enzyme is been proceeding the reaction. So again we will have an introduction to a term that is known as a Vmax, a very important term. So at the low substrate concentration, V0, that is the initial velocity of the reaction, the velocity that is at which the reaction starts, it increases almost linearly with an increase in a substrate concentration. So as you increase the substrate concentration, the velocity of the reaction increases, right? But at a higher concentration, substrate is higher in concentration, the initial velocity increases but by smaller and smaller amount in response to increase in the substrate concentration. For example, when the substrate concentration is low, you will have a very high increase in the, means the linear increase means from 2 molar, if you move towards a 4 molar, right, substrate concentration, the increase will be linear. That is, if in 2 molar the velocity of the reaction is, for example, 10, right, so for the 4 it will be 20, right. Now if you move from 4 to 6, it will be again 30. Like this way the linear increase will be obtained with the increase in the substrate concentration. But once you attain a very high substrate concentration, for example, if the substrate concentration is of 100, now the substrate concentration is not 100, sorry, 15 molar, right? So the increase in the velocity will not be very small amount. For example, at the 80 you are having 96, then 90 you will have 98 velocity, then for 100 you will have 15 molar you will have 100 velocity. So like this way the velocity will differ. Finally, a point is been reached in which increase in the initial velocity of the reaction are vanishing small as substrate increases. So you are getting a point that is a saturation point, we can call it, in which you no matter how much you increase the substrate concentration, the velocity does not increases, right? And that point is called as a maximum velocity, that is a V max. The rate limiting step in the enzyme reaction is a breakdown of the enzyme substrate complex. Now you, in order to understand all this rate limiting step, we in my previous video I have already explained in detail what is the rate limiting step, what is the ES complex, right, to produce product and a free enzyme, right. and the equation is v0, that is the initial velocity, is equals to the vmax, that is the maximum velocity, into substrate concentration divided by Km plus substrate concentration, and your Km is a Michaelis-Menten constant, right? So this equation whole, that is v0 is equal to vmax s upon Km plus s, is a Michaelis-Menten equation, the rate equation for a one substrate's enzyme catalysis reaction. That is, it is a reaction for only one substrate and enzyme for n number of substrate. From the n number of substrate is been present in the solution and the n number of enzyme present in the solution, this is applicable to only to one substrate enzyme, because every enzyme will catalyze this in the similar way as the one enzyme of the same type. It is a statement of the quantitative relationship between the initial velocity. So it helps you to quantize, right? If my substrate concentration is more, right, will my velocity increases? Yes, initial velocity will increase, right? So it helps you to quantitate the relationship between the initial velocity, maximum velocity. What is the relation between v0 and vmax? You come to know initial substrate concentration. All these have been related to the Km, right? Now from the Michaelis-Menten equation, that is v0 equal to vmax s upon Km plus s, if you have a very special case, that is the initial velocity is equal to the half of the vmax, right? So in place of v0 you put vmax by 2, that is vmax by 2 is equals to vmax s upon Km plus x. So you will get 1 by 2 is equals to s upon Km plus s. So that is 1 by 2 is equal to s upon Km plus s. Now you solve for now you take 2 this side, that it will become 2s is equals to Km plus s, right? So now you take s on the left hand side, so you will get Km is equal to s. It means what? Michaelis-Menten constant is equal to the substrate concentration when the initial velocity is equal to the half of the vmax, right? And this is a very useful practical definition of Km. Km is equivalent to substrate concentration at which v0 is equals to 1/2 of vmax. So the reference used over here is Lehringer Principle of Biochemistry 4th edition, right? We are ending this year with the basic of Michaelis-Menten constant. We will come further with many more videos. Stay tuned with us, right? And please share this and upcoming videos. See you soon. Thank you. For more videos and materials or any query, feel free to subscribe us at www.pharmatoppers.com. Thank you.